Okay, so again, I'm Mr. Johnston, and I'm going to be going over perfect squares with you today. So I'm going to share my screen with you. So in your own words, what makes a perfect square? So we know that a square visually has all the same sides. All the sides are the same length, right? So we're going to learn mathematically what makes a perfect square. So here, if I asked you if this quadrilateral is a perfect square, you'd say, of course not. It's a rectangle. It can't be a square. This side is shorter than this side. You know, we can look at it and assume these two are equal and these two are equal, but we're not 100% sure. But either way, it can't be a square, so it's certainly not a perfect square. Is this quadrilateral a perfect square? By looking at it, I would assume it's a perfect square. All these sides look the same, but let's prove it. So let's take these and put them up on this graph. So you can see here that as you count these squares, we're going to call them unit squares. You can see that you count up 1, then 2, then 3, then 4, then 5. If you count across, you get 1, 2, 3, 4, 5, 6, 7. So we know this one is not a perfect square. This one, on the other hand, though, when we count the squares, we can see that we have, let's see if my handy dandy pen will work. Let me get this out of the way. All right, so we got handy dandy pen. Do it in green for just cause. So we have here 1, 2, 3, 4, 5, 6, 7. All right, that's not done very well, but you can see that when you're counting the squares, here we have 1, 2, 3, 4, 5, 6, and 7. So we have 7 and 7. So by our definition of what a square is, that's certainly a square. But an interesting thing is how many of these little unit squares does it take to make this big square? You can sit here and count them. You know you're going to have 7 by 7, 7, 7, 7. So you're going to have 7 rows of 7, right? So you're going to have 7 by 7. So 7 by 7. And that's going to equal 49. Therefore, 49 is a perfect square. So we'll get into that a little bit more. So here's a smaller one just to show you again. A perfect square. See if I can move my big head. A perfect square is a number made by multiplying a whole number by itself. Now the key word here, or key phrase I should say, biggest word here is itself. It's multiplying a whole number by itself. So here we have an example is 3 squared right here, right? So this 2 means that you're going to have 3 times itself. You're going to have 2 3s, 3 times 3, which is going to equal 9. And you can see that 9 is then a perfect square. But just like before, you can count up. That's 1, 2, 3. And then right here, 1, 2, 3. So visually, it's a perfect square because all the sides are going to be the same length. But how many of these colorful squares that we deemed as 1, each side is 1, makes up this big square? And you can count these real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And that's the same as saying 3 times 3. Or 3 squared. That's the notation you want. So a couple important cases. 0 times 0. Anything times 0 is 0, 0 times 1 is 0, 0 times a million, 0, 0 times my house is 0, 0 times 0 is always 0. Remember we have this 2 here, so that means it's going to be 1 times another 1. There's 2 1s, 1 squared, 1 to the second power, 2 1s, 1 times 1, which also means -1 times -1. Now we know that 1 times itself is going to be 1. We also know that a negative times another negative makes a positive, right? So that's how this works. So -1 times -1 equals 1. And you can test this out on Desmos. So I'll show you the first thing that we saw was 1 squared. That equals 1. Then you have 1 times 1. That also equals 1. Let's try -1 times -1. Also equals 1. So if 1 times 1 is the same as 1 squared, then doesn't that mean that -1 squared should also equal 1? And see, it does. Key when you're doing when you're squaring a negative, make sure you put parentheses around it, or else that negative's going to stay on the outside, and it's just going to square the 1, and then you end up with a -1, which would be incorrect. So I'm just going to go through a couple of these since we did a bunch of this in class, and there's a key. So you'll have 2 times 2. Again, if you have this little 2 here, you're going to have 2 of whatever this bigger number is multiplying each other. The same number, multiplying by itself. 2 times 2, -2 times -2. 2 times 2 is 4. -2 times -2, 4. All right. Like I said, we did a lot of these in class, so I'm not going to do all of these. You should, at some point in the year, sooner than later, it would be helpful if you just memorize all of these. So 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared, is 100. And again, you want to remember that since these are already written out, 4 squared is 4 times 4, but it also is -4 times -4. Okay? So I'll show you the key here. I'll leave that up for a second, so you guys can rewind this. I'm going to take a screenshot, make flashcards knowing that this side right here is equal to this side, right? All right, so our next set of these is going to be through 20. Now, I'm not gonna lie, I don't remember all of these off the top of my head all the time. But just like we did before, I'm gonna go ahead and say 11 squared is 11 times 11. Remember, you have this little 2 here. This is 11 to the second power, 2. You're gonna have 2 11s. You're gonna have an 11 multiplied by itself. It's also the same as -11 times -11. And the reason here is because a negative times a negative makes a positive. This will be 121. 12 squared is 144. I'm going to do the ones I know offhand. 13 squared is 169. 14 squared is 196. 15 squared is 225. Now, just so I can show you a little bit more on Desmos, let's try 16 squared, right? So bam, pull up Desmos. Let's do 16 squared, 256. Let's just prove it though. 16 times 16 is 256. -16 times a -16, again, 256. And just for fun, for practice with using parentheses, because that's important, when you square a -16, you get 256. And you can see that they're all the same. So again, you're going to have, oops, there's my pen. What was it? 256. Okay, so you have a couple different ways that you can solve for this. Easiest thing is probably just, oops. So you go 17 squared, 289. So go ahead and pop that in. And honestly, between going through it in class and you guys having a key and being able to pause. I don't think you should have any issues really with that. Here's the key again, though, just to finish the rest of them. And again, you're just making sure that you understand that all of these numbers squared are equal to this. And the more you remember, the less, calculator math that you'll have to do. So now, when you're taking the square root, you think about what number times, and making this before class, so I'm hoping somebody guesses this in class, but it's times itself. Okay? So it's the same concept, just backwards. It's the opposite. It's actually the reciprocal function. So if I have the square root of 0, what two numbers that are the same number, or what number can I multiply by itself to get 0? So it would be 0 times 0. So the square root of 0 would be 0. Similarly with 1, what number times itself can I multiply to get 1? I get 1. 4, 2 times 2 equals 4. So 2 is the square root of 4. This symbol right here means square root. All right, so what two numbers can I get for 9? I could do 1 and 9. They're not the same. What are the factors of 9? Let's do that way. Factors of 9 are 1, 3, and 9, right? So we know that 1 and 9 multiply by each other, so that's not going to be it. But 3 times itself is going to equal 9. So that means your answer, and I should really do this, is going to be 3. And this is not, I mean, those are correct, but it's what the square root's going to be is the main focus. All right, so you want to look for factors is an excellent way to do this. So if I want to look for the factors of 16, let's try 16 over here, right? I've got 1, 2. Is 3 a factor? No. 4. Is 5 a factor? No. Does 6 go into 16 evenly? No. 7? No. 8? Good. 9, 10, 11, 12? Nope. It's going to be 16. So we know 1 times 16 makes 16. We know 2 times 8 makes 16. So those aren't going to do us any good. But here, we know that 4 times 4 is going to be 16. So that's going to be the square root of 16 is 4. So you want to do this. You just want to find factors for all of these. I've done a bunch of them in class, so I'm not going to go through all of them. Again, this would be helpful if you memorized them, and if you can memorize the original squares, then it's just like going backwards. So we would know that this is 11, 12, 13, 15, 17, 19, 20, 18, 16, 14, 5, 6, 7, 8, 9, 10. And you'll find all these little tricks that you might see like along the way, like 7 times 7 is 49. So 17 times 7 is 289. It ends with a 9. There's just little subtle things that you'll see, like square root of 5, square root of 225, or square root of 25 is 5, square root of 225, it ends with a 5, both ends with 5, 15. So you'll notice little trends like that as you go. Again, biggest word here, it's self. Now, if we wanted to go the Desmos route, which I would highly suggest, I can say this square root button. Okay, the square root button, we use this square button. Let's just going to put me a 2 there. But we use this square button right here where my mouse is. The opposite is the square root button. This is this same symbol that we saw on the Smart dog. So right here, I can put in square root of 49. Well, if I put it in correctly, square root of 49. Bam, I get 7. Square root of 81. Bam, I get 9. Square root of 169. 13. One more. Square root of 400 equals 20. So there's a lot of use you can have with Desmos with this. Certainly make it a lot easier for you guys. All right. So now we'll get into where things start to get a little tricky, because you're not just going to have a question that's, I mean, you'll have a question that says, what's the square root of 121? What's 9 times 9? Or what's 9 squared? Which then you'll know that 9 squared equals 9 times 9, 9 times itself, and that equals 81. But now we want to figure out which of these are in fact perfect squares. So in your head, each of these has a square root over it. Okay? All right, so all of them have that square root symbol over them. And all you have to do is come down here to Desmos. You're going to type in square root, what was the first one? Square root of 111. Square root of 111. Now it has a decimal. That's not a perfect square. A perfect square has to be a whole number. So once you see a decimal followed by a bunch of other numbers, it's not a perfect square. So you can say no to this guy. Let's try 256. And some of you guys already know because we've seen it 3 or 4 times now. 256 equals 16. That is a whole number and is in fact a perfect square. So this one right here would be yes. Let's do a couple more and then I'll just show you the key. Again, this is just calculator math, not a problem. Divided by 66, you get 8.124 and a bunch of other numbers. What do you see first? Decimal. Can't be a perfect square. And we'll do 36. Square root of 36, bam. It's a whole number, 6. So this one is in fact a perfect square. Not just off of memory, some of you probably already know that this is definitely one, this is definitely one, this is 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 one. And then for the ones that you're not sure about, like 333, let's just try that. Square root 333, 18 and a bunch of decimal. So that one is going to be a big old negative. All right, you guys can work with the rest of these. Like I said, we'll have done a bunch of this in class. And there's your key. It's recorded, so you can screenshot it. So then we have another one of these. I'll just do a couple. First step, though, is you guys have to visualize each of these numbers has a square root symbol around it. All right, so we're going to go to Desmos again. Square root 289, 17. It's a whole number. Excuse me. So this is a yes. Everybody should know by now that 1 is a whole number. 196. I'm going to take a guess and say that it is. Oh, that's double square root. We don't need to get into all that. 196 is going to be 14. So we know that this is a yes. 20. We'll try this one. 100 should be another one that stands out to you. That's definitely a yes. So let's just test 20. I'm pretty sure we all know that it's not, but bam, decimal, not a whole number, can't be a perfect square. All right, and here's your key for this one. Again, remember, biggest thing, need y'all just to remember, each of these numbers has this square root above it. All right. So we have a couple more slides to go. If your friend asked you to be at his house between 6 and 7, what exactly does that mean? What times would be acceptable for you to be there? What times would not be acceptable for me to be there. So let's say I have a buddy. He tells me I can be at his house between 6 and 7. If I get there at 6:30, I'm good, right? Oops. But if I get here at, say, 7:10, I'm late. And if I get here at 5:45, I'm early, right? So you want to be in between 6 and 7. So this is where you start talking about consecutive squares and square roots. So when you're looking for consecutive numbers, this means you're looking for two numbers next to each other. For the two numbers next to each other that it falls between. So the consecutive part of the numbers that are next to each other. So like 1 and 2 are consecutive, 4 and 5, 9 and 10, 586,001, 586,002. Those are all consecutive numbers. And of course, we won't get up to that high of a number, or at least I hope not. So which two consecutive numbers does square root of 50 fall in between? So let's take what does the square root of 50 equal first? So what are we going to use? Desmos. Square root of 50. You get 7.07. All right, so let's just round that off there. We'll say that that's, oops. We'll say that that's roughly 7.07. Now, what two whole numbers does 7.07 fall in between? So if I have a number line and I have, say I have 6, 7, 8, and 9, right? So 7.07 is greater than 7, right? So it's going to be bigger than 7, but less than 8. So therefore, it's going to fall in between 7 and 8. Your answer is 7 and 8. So again, coming right for Desmos, square root 47 is 6.855. So we will just round that off. You could honestly round it off at the 10th if you wanted to, that's fine. Oops. So I'm going to do that. Square root of 47 equals roughly 6.9. And what's that in between? I'm going to put a 5 here. I'm going to put a 6. I'm going to put a 7. I'm going to put an 8. Because those are the most likely answers. Now remember, we have 46 and 48 here. That might trick somebody, but it's not going to trick any of you guys. Because remember, the first thing you need to remember is that this square root symbol means you have to do something with the calculator or memory if it's a perfect square. So 6.9 is greater than 6. So it's definitely going to be past 6, but it's less than 7. Definitely be smaller than 7. So it's going to be right in between 6 and 7. So we know it's not A, we know it's not C, and we all knew from the beginning it was not D. So your answer is B. All right, now let's do it a different way. So now we're looking for one that's in between 16 and 17. So there's two ways you can do this. I'm going to show you my way, my favorite way of doing it. And that I think is just going to be the easiest way. And that is you take all 4 of these numbers, put them in Desmos, see where they show up on a number line. So let's try square root of 157. And we get 12.529. Well, that's way down here somewhere. That's way down here, 12.5. So it's not going to be A. Let's give B a shot. Square root of 231, 15.2, right? 15.19 rounded off at the 10th. So that's going to be a little bit closer, but that's still not in between 6 and 7. We need it to fall somewhere in here. So bam. No, it's not B. Let's give C a shot. Square root of 270. I have a feeling this one's going to be good. 16.4. All right. We're looking pretty good here. I'm thinking this is probably the answer, but I'm not going to circle it yet. You'll hear me say this a bunch over the course of the year or semester. But always check all the answers because you never know. Like sometimes these test makers will throw in, they may be, I don't know. You just never know. Always check all the answers. Don't stop just because you think you have it. Confirm that everything is not right. So square root of 300 is 17.3, which we can confirm is going to be out here somewhere. So we know that this is definitely not right. It means that C is right. Okay. And last but not least is you'll see a number line like this. This is why I was trying to introduce the number lines a little earlier because I knew this was coming up. And you guys aren't going to have any problems with this because we're going to go back to everybody's favorite friend, Desmos. Square root of 55 is 7.4161984887. We're going to round that off to 10th. So it's going to be 7.4. If you have any questions about rounding, don't hesitate to ask. So here we have square root of 55 roughly equals 7.4. Let's see, so where's this dot at? This dot right here is right at 8, right? So he's gone. This one's bigger than 8, gone. This is even bigger than 8, gone. This is just before, this is right here is 7.5, right? That's what this line is. So this dot looks like it's 7.4, which means that your answer is A. Okay, so that's pretty much what we went over today, September 9th. If you guys have any questions, don't hesitate to email me, message me on Schoology, whatever works for you. I appreciate you checking it out. And don't forget that Desmos is your friend, and the link for this specific Desmos calculator is in the Schoology course. So have a good evening, and I will see you guys in class. And whenever I figure out how to make this stop recording.